All right, everybody. Good evening and welcome to the De Anza College's In the Cosmos live virtual star party. My name is Toshi Komatsu and I am the director of the planetarium and one of your hosts here for the event. We also have with us Mike Askins. Go ahead and say, Mike, say hi to everyone, Mike.
Hello, everybody. Welcome to the virtual star party here. I'm out in my backyard with my telescope, my phone attached to it. And so hopefully we'll be able to show you some nice views of the moon tonight. It's beautifully clear out here tonight. I hope it's clear where you are too. Back to you, Toshi.
All right, so we have again a very nice program, hopefully scheduled for you, and hopefully you're logged in with a mobile device so that you can go out and check out the real sky as well. We'll be focused on the moon. You can already see that Mike has his telescope focused on the moon, and we'll get to that in just a little bit. But for now, we thought we'd start off and take a look at the sky and point out some constellations that you can find in the real sky. Hopefully for yourself here. Before we do get started, we do want to thank the Foothill De Anza Foundation for their support in doing these virtual star parties and with the captioning, which again, hopefully is available for everybody. And like to wish everybody a happy spring equinox, vernal equinox that occurred this morning at 2:37 Pacific Daylight Time. So happy spring. It's the official beginning of spring here. So hopefully everyone is enjoying. We had just finished having a rainstorm here locally, and I think we're supposed to be in the clear, at least weather-wise, for a little bit. But thankfully, and Mike was verifying this earlier, we have some nice clear weather for us here. So why don't we go ahead and get started? Let's see, Mike, is there anything you want to say about the equinox that you think that folks should know?
Of course, equinox means equal day and night. So we're having days and nights, which are about the same duration, to within very close tolerance. And I don't know, I don't really notice it. I've got so many other things going on that I don't notice whether or not the day and night are exactly the same length, Toshi, but that's what equinox means. And yeah, I wish everybody a happy equinox.
All right. Well, why don't we go ahead and let's see if we can take a look at the evening sky and see what that looks like for everyone here. So we'll switch over my view over to Stellarium, which is a bit of software that we're using here to take a look at the evening sky. And right now I've got Stellarium pointed over towards the west. So if you're outside with your own devices looking towards the west, this should be pretty similar to the sky that you're seeing if you're looking at it locally from the Bay Area. So we're looking towards the west. Several bright constellations. Again, we'll focus in on the moon in just a little bit, but there's a few constellations that I do want to make sure that people can find tonight. And even though we're heading into spring and leaving the winter sky, there are several bright winter constellations that we'd like people to be able to find in the sky. And I'll start off with this constellation, was probably the most famous one that I'm circling here in my view, and that is a constellation here, which several of you probably recognize, 3 stars all in a row all in a row here. And there's 3 that are just about the same brightness and in a line there. Let's see here. We'll go ahead and turn on the stick figure for Orion there. There's more to Orion than his belt. And I think maybe let's see. So we've got Orion and his famous belt there, and I'm going to go ahead and sort of center in on Orion. So looking a bit towards the southwest here a little bit, and I'm going to zoom in a little bit more here, just so that we can get a better sense of Orion. So we've got Orion and the artwork for Orion. Orion, according to legend, was a great hunter. So here you can see sort of the artwork picture for Orion, great hunter with his famous belt, and he's got his sword hanging from his belt. Got 2 shoulder stars there, known as, there's Betelgeuse. The star is actually called Bellatrix. If you're a fan of Harry Potter, you've heard that name before. And then we've got Rigel here in his foot, and then his other foot here. But that's a famous winter constellation. Again, lots of bright stars that make up Orion there. But you can use Orion and the stars around him to find your way around the sky. That was a little bit faster than I wanted. But if you take the belt stars and you go along this way, a little bit more towards the west, there's a very bright red star there in the sky. Maybe you can see that in your real sky. Again, taking the belt of Orion and heading towards the right, or a little bit more towards the west there, a bright star there. That's a star called Aldebaran, is the name of that star. And it's part of another constellation. Orion there is fighting a great animal there in the sky, and that is a bull. So we can see both Orion and the bull visible there in the sky. And that bull, some of you probably know, his name is Taurus, the bull that Orion is fighting there in the sky. A few too many things in the sky, or in my sky here at the moment. So we've got Taurus the bull there that he's fighting. Right now the moon is sort of in Taurus. We would say the moon sitting in Taurus, right between the horns of Taurus tonight here. And if we were to, again, just sort of take a look at just the dot to dot version, right, sort of in between there. So if you are looking at the moon in the real sky, if you see those two stars on either side of the moon, those are going to be the ends of the horns of Taurus the bull there. Next up, as we sort of continue our kind of tour around the sky, we're pointing out several constellations with those bright stars. We've got Aldebaran there. There's another star up here called Capella. That's part of a different constellation. That's a constellation called Auriga. It actually shares one star with Taurus there. And Auriga was a charioteer, so someone who drives a chariot, and he was also holding a goat. So Capella, sometimes referred to as the goat star. That's Capella in Auriga. Next up, we have a couple of other stars a little bit higher up in Gemini. We've got the two twin stars of Gemini that are known as Castor and Pollux. See if I can get their names to appear. Looks like Stellarium doesn't want to cooperate there, but we've got Castor here and Pollux. And then if we continue going around, you may notice that I am kind of going around in a circle, starting from Rigel to Aldebaran to Capella, through these two bright stars that are almost the same brightness in Gemini there. And then we can make our way to Procyon. Some people say Procyon, but I say Procyon. That's part of a constellation that's not very big at all, just a couple of stars that make up a short little line there, making up Canis Minor there in the sky. And that, of course, is the little dog there. Again, getting a little bit crowded on my screen. But then if we continue along, going from Capella through Pollux and Castor, Castor and Pollux, and through Procyon, then we get to the brightest star in the whole sky. That's a star called Sirius. No joke about that. It's actually called Sirius. And if you've got a Sirius XM radio, this is where the name comes from the brightest star in the whole sky. And that's also sometimes known as the dog star, because it's a part of Canis Major, the big dog, or the great dog there in the sky. So these are 6 very famous winter constellations. And again, if I back away from the sky here a little bit, maybe turn the artwork off because it's a bit much here. But if you take these stars, again, now they're looking low in the west, southwest. But you can take a look in this part of the sky here and again, find several bright stars. And one thing that some people like to look for is something called the Winter Hexagon. And you can start again from Rigel, make your way to Taurus, up to Capella, through the twin stars Castor and Pollux in Gemini, Procyon, and then to Sirius and back to Rigel. That's a nice hexagon of 6 or 7, if you count the twin stars in Gemini, bright stars there that make a very large hexagon there in the sky. And of course, what we're focused on here tonight for the next several minutes, I'll turn it over to Mike and his telescope in just a moment here, But what we're focused in on is the moon. So what I'm going to do is I'm going to go ahead and
Before you switch there,
yeah.
there is a little visitor that's sort of close by Aldebaran.
Yes, you are correct in that.
Let's take a look
So
at that.
yeah, so Aldebaran is quite low in my view here. Let me make that a little bit higher. It's a reddish object there. That's Aldebaran. But next to it is another reddish object right next to it there. It's almost the same brightness, not quite as bright as Aldebaran. And it's a wanderer in the sky. And some
Hmm.
of you maybe might put in the chat if you know what that wanderer might be. It's pretty famous. It's been in the news, especially in the last last month or so. There was something very excited that happened with this particular object.
And its
Uh,
color is significant, right, Toshi?
and its color is significant. It's got a bit of a reddish color. Wanderer is another name for planet. The word planet actually comes from ancient, is it Greek, Mike? I always forget if it's Greek or if it's Latin, but I think it's ancient Greek, planetes or planetes, which means wanderer. But that is Mars in the sky. In Stellarium, I can zoom way in and we can take a look at Mars close up. Doesn't look this good in a telescope, and that's because Mars is still relatively small. It's about half the size of Earth. But if I got way close in and we had a really powerful telescope, unfortunately, Mike's telescope isn't quite that powerful, but this is the sort of detail that we can see here in Stellarium. And Stellarium is free open source software. You can download it for yourself on your computer. It's available for Mac or Windows, even Linux. If you're if you have a Linux box, but that's Mars. If you could see it through a very powerful telescope tonight, and it's been in the news because there are several spacecraft that have made it to Mars just very recently. There was earlier. There was a mission from the first time, or for the first time, from the United Arab Emirates. And that was the Hope Mars mission, and that's designed to study the atmosphere. Arriving just a little bit after the Hope probe is the Tianwen probe from China, which arrived a little bit later, and that has an orbiter, a lander, and a rover. But the big news for us in the U.S. is that the Mars 2020 Perseverance rover landed on February 18th. And I know I was able to watch it land through NASA TV. I know, Mike, you watched it as well.
It's really spectacular, Toshi. It's amazing to me how they can program all that stuff to work flawlessly the one time that it's necessary. Just you and I tonight trying to get the telescope set up. It's hard to do to get, I have trouble with just real simple things, but these guys have issues, thousands and thousands of issues, and they seem to work through all of them. I was really quite amazed with how well it worked, and I was very excited about it too. I know you were also, Toshi.
Yeah, it's a very, very exciting time to be studying Mars, and there's a whole suite of mission or instruments on that rover Perseverance. There's also a helicopter that they're going to be able to fly around for the first time, and that's a rather exciting thing. It's kind of like an oversized drone. But you have to contend with a lot of things, like the atmosphere on Mars is much thinner. And so the rotors on this helicopter, they're much larger than a rover or than a drone that you might pick up at locally here on Earth. But they're going to try flying a helicopter and see see how it goes. But I think that's probably enough about Mars. So I'm going to go ahead and back away, and we'll go ahead and check out that Mars is also kind of close, not only to Aldebaran, the bright red star in Taurus, which forms the angry red eye of Taurus the bull, but it's also not that far away from the moon as well, just a little bit higher than Mars in the sky here. So while I could zoom in on the moon, I've highlighted here, but I could zoom on it. But Mike, you've also got your telescope again trained on the moon. So why don't we go ahead and switch over to your view through your telescope, and
Okay.
you can give us a little tour of the moon.
Great.
It's a nice night for looking at the moon, isn't it?
It's just beautiful out there. So thanks for highlighting me. Let's just hang on for just a second here. I'll go ahead and see if I can zoom in here.
Yeah, and we chose this night specifically to be looking at the moon because it's a very nice quarter moon phase that we're looking at. And that's usually a good time to be looking at the moon. Sometimes when people are first getting into observational astronomy, they get excited about the moon, and it's an easy target to be looking at. But one thing about the moon is that a lot of times people want to look at the full moon, and it ends up being very, very bright. And right now, I know, Mike, you're trying to get the exposure right with your view here. But when it's too bright, then it just kind of washes all the detail out, and you also you can it's not like hurting your eye as if you were looking at the sun, but it can sort of like it can feel a little bit painful to your eye just because if you're looking through a telescope at the moon, it can seem super bright, much brighter than is comfortable here. So Mike is getting zoomed in on the moon so that we can take a look. And the most interesting parts of the moon, Mike sort of panned over a part of the moon where it's fairly bright, but as he's making his way over to the terminator, which is the boundary between the nighttime side and the daytime side of the moon there, you notice that things just look a lot more interesting. There's a lot more detail that you can pick out there, and those shadows really give the moon a lot of depth. I like to think of it as a lot of character that we can see on the moon.
So Toshi, there's things are looking a little bit better here. Let me go ahead and it's a little tricky for me to control things here the way that the telescope is set up here. I'm going to try and bring it back here. There's a crater by the name of Walter that's right in the middle, and you can notice it because it's got a little dot right in the center. And as we look at a lot of these craters, we're going to notice that a lot of them may have those central peaks in the middle. And the central peaks are interesting because it's sort of difficult for us human beings to comprehend the amount of energy that's released when a large meteorite hits the surface of the moon. But it actually can, what can happen is the floor of, or the surface of the moon can actually liquefy due to the heat, to the heat of the impact. And all of that kinetic energy turning instantly into something that can melt rock is really quite amazing. And what will happen is, just as we are able to see in little when droplets go into water, sometimes you see little bits flying up in the center. That's the same kind of thing that's happening with these craters. And that one, that Walter, actually, if you look at the right in the center there, you can actually see, I can see a couple of little bits right above it. Also, let me make sure that everybody understands that right in the middle of that crater, parts of it are starting to experience sunrise. And Toshi, maybe you can talk a little bit about that, the way we're able, if you were on the moon, that sunrise takes a lot longer than just a couple hours, right?
Yeah, so the sun rises every day here on Earth, but on the moon, a day on the moon, that is to say, going from sort of night to day, that's something that takes 2 weeks. So there's sometimes people talk about the dark side of the moon. Generally, what people really mean is the far side of the moon. But we get our day and night because we're rotating, and we do that every 24 hours. But the moon takes a lot longer to spin around on its axis. So sunrise is something that takes a lot longer on the moon. And right at the center of that crater, again, that little bright spot is again sort of a central peak that you get in that that crater. And I'm going to see if I can bring up sort of a side-by-side view of a map that I have of of the moon that anybody, and we'll share the link maybe in just a little bit here, but there's a map of the moon that I'm looking at, and I've got it centered on a very similar area to where Mike has his telescope set up, again, right on the Walter crater there. And in this view, which you can get from NASA, and you can set it for any time on the hour throughout the year. So this is the sort of shading that we see in the that I have on my map, is a sort of shading and texture that we see through Mike's view of the telescope as well here. So we've got Walter centered there. Again, you can see that central peak. But I'll switch back over to
you can
the
see
telescope view.
And Toshi, alert viewers will recognize that my telescope has a mirror, a secondary mirror that's in the optical path. And what that does is flip the view from left to right. So as you're looking at the map, you actually have to take into account the fact that the view through the telescope is actually flipped right to left, as I mentioned. Also, look very carefully at many of those craters that are on top of each other. And the reason I point that out is there's a very simple way of understanding sort of which craters are younger and which craters are older. For example, if Walter is the one that's got the central peak there that I was talking about, it's very close to the middle, not quite there, and I don't want to touch it at the moment here. But down below to about, I'd say 6:30 or so, if you were to make the face of a clock around the center of the crater Walter there. Let's see if I can move it a bit. Maybe I can get the focus back again here.
Yeah, I think I see what you're talking about, and maybe I can bring it up on the map as well here. So if we go ahead and take a look at the map, you're talking about sort of just sort of, again, below here a little bit. There's a crater that actually looks like it's on top of another crater there. I think that's what you're talking about, right, Mike?
Now, Toshi, it looks to me like the SVS map is actually flipped top to bottom as well. So why don't we go back to the telescope view, and I'll try and, because they're going to have to flip it sort of both ways there. It's below and slightly to the left of where Walter is. There's a big walled plain. It's very, very flat, and several craters are on top of it. And what you can glean by looking at which ones are on top is which ones came down and struck most recently. So, for example, let's see, we're looking at that big walled plain that I'm talking about is called Stoffler. And right on top of Stoffler, a little bit further over to the right and a little bit, left and a little bit down, is another crater, and that one is a smaller crater, and that one's called Faraday. Stoffler is about 75 miles across, that flat plain there. It's got several other little craters there, and that one that's right on top, that's the biggest of the ones that are on top, is about 43, 44 miles across, something like that. But by looking at that, you can actually tell that Stoffler is older because it's underneath. And if it wasn't underneath, you would see the whole thing. If it wasn't the latest one that's hit, if it was the latest one that's hit, you'd see the entire edge of the crater. Maybe you can say that a little more clearly, Toshi.
Yeah, so I've got it. I think again, I was tricked by the lighting that's on your telescope view versus the lighting and the exact shadowing that's shown here on the map. But here's Stoffler here that we're looking at, that wall plane, and then you're talking about these craters here. And in the picture here, which is taken from actual imagery taken by NASA satellites here, that there's one crater that's sitting on top of the other crater over here. And so you can tell that this crater is newer because it's sitting on top of this other crater that we can see here. And
And
even in this picture, which has an even higher or an even smaller crater that's sitting on top of that crater. So a lot of times on the moon, you get craters on top of craters on top of other craters.
yeah, this is happening over billions of years. So it's an amazing sort of reconfiguring of the surface that's happening sort of continuously throughout time. If you look at Walter again, or Walther as it's actually depicted here, you can see that there's one right on the edge of Walther that's actually, it's got to be more recent than Walther itself because it's on top. It's superposed, an astronomer might say, on top of Walther itself.
And this is how we date things throughout the solar system, not just on the moon, but if you're trying to characterize the ages of craters on Mars or on some of the other moons out there, there's a whole science behind counting craters and seeing which craters are on top of other craters. And that helps with dating all of these craters on all these different worlds.
Well, and of course, Toshi, there's also radioactivity. If you measure what the radioactivity is in rocks that you bring back from the moon, that helps you quantitatively sort of figure out not just relatively which ones are newer or later, but actually, you know, to attach them to a timeline. Maybe Toshi, you could move back to the telescope here, and I'll do a little bit of moving around a little bit further here. We'll see if we can find some of the other features here. Let me go back to the script there.
Yeah, and again, if folks are outside looking up at the sky, hopefully it's clear for you where you are. Again, hopefully you can make out Orion like we were pointing out before, and noticing the moon again right in between those two horns of Taurus the bull. But again, nice night. So I'm told. I'm inside, but
Well,
I'm told
Toshi,
it's a beautiful night out there.
I just looked up again. I have been staring at my laptop, but it is gorgeous up there. The moon is just so pretty. I hope people are out able to take a look at it. Let's see. There's another one that's further north up here. We're going from south to north, and that one has got another crater on top of it. It's called Albatignius, and it's also got a central peak. And I'll try and put it right in the middle here, so that folks will know exactly sort of which one we're talking about. Now it's right in the middle.
Yeah, I can see it there, right centered there. Slightly out of focus. I wonder if you could try to touch up the focus just a little bit, but I do see that there's a bright central peak. And then from our view sort of at the maybe about the 4 o'clock position from that central peak, there's another crater inside of that crater there.
Let's see if I
maybe
can
while you're
there we go. That's a little better.
Yeah. And again, we can switch over briefly to the map to take a look at that crater that you're talking about with Albatignius. And looks like on the map here, it's labeled Klein as the smaller crater in there. And again, right next to another nice central peak. And again, a little bit of shadow, at least on my map here, that shadow pointing sort of towards the 3 o'clock position. Right towards Klein as well. Again, this was sort of calculated by NASA how the shadows are going to fall. And then again, if we switch back to the telescopic view, we can see that it's off by just a little bit. Again, the time that we used was a little bit off, but again, it gives you a good sense of of how the shadows change.
One that's just above there, Toshi, that very large one that's largely disintegrated to a certain amount there, is Hipparchus. Hipparchus is a little bit bigger than Albatignius, and it's got a couple of a central crater and another crater up. Let's see, on my view here. It's about 9:30 or 10 o'clock. If you were to make the center of the face of the clock right in the center of the crater there, that one Hipparchus.
Yeah, and that's another beautiful crater. Again, it's that's again probably an older crater. It's been sort of worn down a bit. And we don't have weather on the moon like we have here. So a lot of that erosion comes from you have micrometeorites and other things that are constantly bombarding the moon there. Um, but I do see we have a few questions, maybe, Mike, as you kind of sort of pan around the moon a little bit. We'll leave it on the moon, but a few questions that have come in through the chat here about
Great.
how did the craters get their name from who discovered them? How long have astronomers been studying the craters? So as far as how long astronomers have been studying craters, I would say probably since the invention of the telescope, and that was about 400 years ago. Galileo is the first one recorded to have used this newfangled invention that he had heard about and turned it towards the heavens. And one of the things that he looked at was the moon. But the names of craters on the moon, a lot of them are scientists, not necessarily the person who discovered the crater. Um, but Hipparchus lived well before the invention of the telescope. But a lot of them have names of various scientists throughout history, not just since the invention of the telescope.
No, there's a huge number of, I mean, just about every little feature has got a name on it. You can look up, if you take the map, for example, and just start doing web searches, you'll find all of them. Lots of astronomers, lots of mathematicians, cartographers as well, because of course this is a, there are a lot of people who are studying the moon, trying to draw it carefully to record what they saw. So a lot of cartographers are on the list there too. There are a couple of very flat areas to, I'm sorry, Toshi, if you've got more questions, maybe we should take a couple more. What do you think?
Yeah, there's a couple more that have come through. There's another question about why does NASA not send rovers to the moon, only to planets like Mars? The moon is so interesting. I agree. I think Mike would agree as well that the moon is very interesting.
Yeah.
Mars, I think, has a lot of appeal because of all the planets in the solar system. It's the one sort of most like Earth in that it's a place where uh, probably we could set up humans and to set up a colony on Mars, as opposed to Venus, where the surface temperature is like 1,000 degrees, or the gas planets, where there's no solid surface to be on. So Mars has a lot of attraction. But there are plans to send more missions to the moon. There are several probes that have been sent to the moon, both, of course, during the Apollo missions 50 plus years ago now. But we've also sent more recent rovers and probes to the moon to study it. So we're still actively studying the moon. But I'm not entirely sure why NASA hasn't sent any rovers. I think Mars just has a little bit more of an appeal at the moment. But there are plenty of lunar scientists, I'm sure, who would love to have a rover on Mars. Just like there are plenty of scientists who, specialize in Mercury and would love for a space probe to be sent to Mercury. But a lot of the effort at the moment seems to be concentrated on Mars.
Toshi, as I'm listening to you, I'm looking at the view here, and I'm noticing that we're really seeing a lot of not only the really rugged highlands of the north part of the moon there, but also some of the mares. And we haven't really talked about the reasons that the mares look different. And maybe you could do that while I try and keep the focus here.
Yeah, so the mare are the smoother areas. So on the view through Mike's telescope there, it's sort of, there's a large circular, it's a little bit of a darker gray, and to the left of the shadowed region. So in that large circular area there is one of those maria, or singular mare, which comes from the Latin, I believe, for oceans or seas. And that's because when people were first looking at the moon, they imagined that there are big oceans of water on the moon. And once we had telescopes that were good enough, we discovered that there weren't any oceans there at all, that they're flat plains. And what we know today is that they are places where when the moon was very, very young, there was lava that flowed on the surface of the moon, just like lava flows from volcanoes here on Earth. But where that lava flows and it cools, it covers up older craters and fills them in and makes them sort of nice and smooth. And then after it's cooled down, if you see like there's a small little crater that I can see right inside of that larger Maria that we see, the dominant Maria over there on the left. And that again, if you're talking about dating things with craters, that crater would have been younger than those last lava flows, which happened something like maybe 3 billion years ago. Those last lava
Now,
flows.
Toshi, the mare that really big one that you're talking about, I believe, is Serenitatis.
Yes, I think you're right about that. So the
And
Sea
that
of Serenity.
and that lonely little crater that's out there, my map says that is Bessel, only about something like 16 miles in diameter, not a lot, very small.
Yeah, very small, but again, very, very striking again with the shadow that we can see going into the crater there.
Yeah. Let's see. Is there another question, Toshi? I'll move.
There's a couple more questions. There's a question about why so many craters on the moon and not on Earth, and that's an excellent question. And the main reason is because on Earth, we have a lot of things that erase the craters. We have things like weather and wind and erosion and even earthquakes and the shifting of the continent. So all that is constantly refreshing the surface of planet Earth. And things are getting covered over. And some of the larger craters we didn't realize until we started taking satellite views that they were craters because they were so wide across that it just kind of looked like, it's kind of a circular mountain range, but a good portion of it might have been eroded. So you might just be seeing a part of that mountain range or a part of the crater wall. So a lot of the craters on Earth have been erased over time, over the billions of years. But on the moon, because there isn't any weather and there isn't any geologic activity. Actually, geologic is not the right word because this is the moon. And so I suppose it would be something like
selenographic or something like that,
selenographic, selenologic, maybe from Selene for the moon. But we don't have those effects on the moon. The surface does change very slightly because you do have larger meteors that come in and meteorites that strike the surface. But for a large part, to a large extent, the surface of the moon, there isn't anything much happening on it to actively change the surface anymore. And that's why we find so many craters on the moon and not so much on Earth.
One thing that we should point out, Toshi, which I think we neglected, was that if you look very, very carefully at the image there, you'll see that it looks like it's underwater. And in fact, it is in a way underwater. It's under a liquid. It's under our atmosphere. We're looking through our atmosphere in order to see our constantly thermally changing atmosphere. And that's what sort of gives it that look like if you look on a hot day and you look out over a large hot plain, you a lot of times will see, you'll see those heat waves. And that's sort of what you're seeing right there. And it's one of the reasons that I'm having trouble keeping the focus is because my phone is constantly looking at the image and it gets confused about the blubberiness or the underwaterness and refocuses at certain times when it shouldn't. So anyway, but that's one of the reasons that astronomers like to make telescopes out in space as opposed to on the Earth, because when they're on Earth, you have to look through this ocean of air. And when you magnify the image of what you're looking at, you also magnify the distortion as well.
Yeah, all of that distortion is why I often say that, astronomy would be much easier if we just didn't have an atmosphere. That pesky atmosphere gets in the way of so much good astronomy. Now, some people, I think you're one of them, Mike, seem to disagree about the atmosphere.
Hershey, I think you should just go for a few days without air and see what it's like.
Well, that is a reason why, a little bit more seriously, there are some plans that people have talked about setting up, again, station on the moon that perhaps would have a telescope, and then you would get some very nice seeing from the moon, because again, the moon, because it doesn't have an atmosphere, wouldn't have that sort of distortion. So there could be some really good astronomy done from the moon, observational astronomy with different observatories there. While you're repositioning there, a couple more questions that have
Okay.
come through the chat. Um, Carol mentioned that she noticed that there were marks on the map that I was showing for Apollo 11 and 16. So the question is, how did NASA decide where the moon missions would land? And I don't know if you have any particular knowledge of that, Mike. I know there are several things that go into deciding on a landing spot for any sort of lander, whether it's on Mars or the moon or anywhere else. I think with those early, especially with Apollo 11, they wanted someplace relatively flat. They wanted someplace that didn't have maybe a whole lot of rocks, so that it would be as easy of a landing as possible. But sometimes there are more scientific reasons to choose a particular site, because you are doing sort of orbital studies and you find out that there are certain minerals in an area, or that there's a certain interesting geography or certain features that you're looking at. So a lot of times there are scientific reasons to choose the sites
Well,
for where you're going to land.
I do know, I do remember a little bit about some of the work that they were doing. They were also very interested to try and go to different places that help them understand the different layers of material, the different colors, and the different composition of the different layers. Like we have the darker areas. There in the highlands, there are lighter areas as well. And so sometimes also I saw that they looked carefully at landing near one of the rays of the crater Tycho, because they wanted to see what some of the material that was dug up from a depth during that impact.
Yeah, so there are all sorts of things that go into the decision for landing, and depends on again, your scientific objectives. So seeing the different parts of the moon. Again, there was not a whole lot known about the actual mineral content of the moon until we started bringing some of those samples back. I know that there was some concern that I'd heard from, like, with the early Apollo missions, like Apollo 11. Um, there was a school of thought that the surface of the moon was actually quite soft, and that when the lander would when it landed, it might be a little bit more like really soft sand or like quicksand, so that part of the lander might actually sink a little bit. We found, luckily, that when we landed, that wasn't the case, but that was a bit of concern for some of the engineers, is how do we account for a surface that we don't know how hard the surface is going to be.
One feature I want to point out, it's going right by the middle of the screen there, Toshi. It's a valley. It's called Alpes Vallis. And what that means is a valley that's being named after the European Alps. And you can see it's sort of a linear, can you spot that, Toshi?
Yeah, I
Back a
think I
little
can
bit.
see it. Yeah, you got it near
There we
the
go.
center of the view there.
Yeah, I'll try and get it even closer to the center, so there won't be any question. Whoa! Now it's above the center.
But it's sort of the horizontal linear feature.
I've only had
Uh,
my telescope license for a few weeks, Toshi. So this is why you're having to bear with me here. It's right about in the center right now. It goes sort of straight across. Let's see. There's a couple of craters. There's a crater off to the left. And which one is that? Let me just remind myself. That's Aristoteles. And it's about that linear area, that valley, is about the same the same size as that crater.
yeah, let me switch briefly over to my map, because I think I
Oh,
found
there
the
you
same
go.
thing for you
Yes,
here. So we're talking about this linear feature
that's it.
right over here. Yeah, so That was one of the things, if you like to study the moon and do some selenography there, there are valleys on the moon, there are mountains, again, all these beautiful craters. And again, looking at a time that is not full moon is when you can get, again, those shadows that really, again, give a lot of depth and a lot of character to the moon. And if it were full moon, that valley's still there, but you wouldn't have the shadows to draw your attention to it. It would actually look quite flat. So that's why crescent phases and quarter moon phases, those are usually the best times to be looking at the moon, just to get some shadows there, to bring some depth and give the moon the sense that it's a 3D object and not just a flat thing that you're looking at.
Well, Toshi, I love looking at the moon here, but I know there's a couple other things that we wanted to take a look at. So maybe we should table the discussion of the moon here, and maybe go back to some of the the future constellations that we might see in the next month or so.
Yeah, actually, why don't you leave it on the moon there for a second? A couple more questions that have come in as well.
Okay.
There's a question about what software did we use to view the moon. So that software that I was using is called Stellarium. And that's, again, freely available on the web as a download. There's also a web version where you don't have to download any software, but that's Stellarium at stellarium.org, STELLA. Oh, I'll have to look it up because I'm terrible at spelling on the fly here. But STELLARIUM, Stellarium, like stellar with an IUM at the end. And again, that's free open source software that you can download for yourself or use the web version. So that was one question.
Now, Toshi, maybe they were talking about the map software. That's actually a different program, right?
Yes, and that map software, we've got our admin monitoring the chat on YouTube, but I'll go ahead and make the share that so that she can copy and paste that into the YouTube chat so that you can see. But the map that I was using comes from the Goddard Space Flight Center, from the Scientific Visualization Studio that's run out of Goddard, and that's at svs.gsfc.nasa.gov/4874. That's an easy thing to remember, 4874. But there you can find the map that I've been showing. Again, let me switch over to that briefly so that you can see if you were talking about that map there. This map, I'm just using the Windows photo editor. So this isn't any particular software. This is just something that I'm using to look at this image. Let me back all the way out. This is, again, you can download this image for any hour of any day throughout the year of 2021. And they make these available every single year. So you can download when 2022 rolls around, they'll have a website where you can download what the moon will look like for every single hour. Has some extra information that they put in the corner about how took their information about the diameter and the distance, position, and that sort of thing, and where the moon is in its orbit related to Earth and its exact orientation. But then I'm just zooming in with the just through using my mouse wheel, just to zoom in closer and to move around. So this isn't any special kind of software. It's just an image viewer. So if you're on a Mac, you can do this on Preview. If you're on Windows, you can just use the Windows Photo Viewer app there.
Well, one of the things that I think is terrific about this scientific visualization studio is this program that generates the image makes the image out of thousands of images shot by the Lunar Reconnaissance Orbiter. It's orbiting around the moon, constantly taking pictures of it, and those pictures are used to sort of reconstitute based on the exact position of the moon and its relationship between the sun and the Earth. It makes an excellent fidelity view of the moon, and not only some of the very subtle movements as well, something called libration and nodding. Anyway, there's a lot of different words going on there, but it is a way to see very clearly exactly what the moon should look like. And as you saw tonight, it shows a lot of what we're seeing through the telescope.
Yeah, so again, hopefully our moderator can put that in the chat so people can see. And if, I think maybe after the fact we can put it in the description as below if people want to find again the map that I'm using here. Again, this is just a still image that I'm just using a picture viewer software. Anything will do. But it is a lot of fun to explore all of these different craters right along, again, that shadow there. Again, you can see if I look off to the side, and if we're looking at more of a full moon, again, all the features, you can see craters, but again, they look quite flat and they're not quite as interesting to look at until you look at some of the stuff that's, again, where you get some shadows. That's what gives it the depth there. But we are kind of sort of running up on our time here. But before we go, we did want to go ahead and share with you a little bit more about things that you can find in the evening sky. So again, if you are out tonight looking out or over the next couple of nights, the moon, this is where the moon is. Again, it's sort of low in the west. But what I did want to do is share some springtime constellations that you can be looking for. These constellations, the ones that I pointed out, again, more winter constellations. So they're getting low in the west. You might be able to see them for the next few weeks and into April a bit. But as we start looking towards the south and the southeast and the eastern part of the sky, some more constellations that you might look for. One that I know that I like to look for, a springtime constellation that I like to look for, is this one that I'm coming up over here. We're looking again, kind of in the southeast. Sorry, let me back up again. We're looking sort of in the southeastern part of the sky here, high up at the moment. And there's one bright star there, or the brightest star, and that's a star here called Regulus, is the name of that star. And that star is the brightest star in a constellation known as Leo the Lion here. So we can do the dot-to-dot version, put up the label here, and see Leo the Lion prowling across the sky. So that's a good one to look for. Again, that star is pretty bright, among one of the brighter stars in the sky. And then you have this backwards question mark shape here. Sometimes it's called the sickle. And that forms the mane of the lion. And then there's a distinctive, almost looks like a perfect right triangle there to make up the hindquarters of the lion and his tail. So that's a good springtime constellation to be looking for.
I can see it right here from my backyard, Toshi.
Again, bright star there, Regulus, and then look for that backwards question mark shape there, a nice little arc there. Although it doesn't quite work, I like to think of Regulus there as being sort of the dot at the end of the question mark there, but a nice little hook shape there. Sometimes people see it the other way, and they imagine it sort of this way, if this is the head of an animal, and a tail sticking out that way. Some people imagine this as a mouse, and I can totally see it that way as well. But so you've got Leo the lion. Officially, it's Leo the lion, but you've got the mouse there as well. And just south of Leo is a bright star that kind of looks like it's by itself. This star right over here, that's part of the constellation of Hydra, which is a sea serpent snaking its way through the sky. And the name of that star there is called Alphard, A-L-P-H-A-R-D, Alphard, and that's Arabic for the solitary one. And you can probably tell here, and if I turn off all the pictures here and the labels, that it just kind of sits by itself in the sky there. Nice bright star there. So that's the solitary one, Alphard. And again, known as the backbone of the serpent and the heart of Hydra there. And it's the brightest one, but if you can see the rest of Hydra, it's sort of a zigzaggy shape there, but none of those stars are very bright. But Alphard is one that you can find fairly easily in the sky. Again, sort of south of the hook of Leo the lion there. And then one more that I'd like to point out as we sort of start to wrap things up, looking more towards the north. At the moment, it's kind of in the northeast here in my stellarium view. I've got a building down here, but we're looking almost exactly right above northeast. Again, one of the most famous shapes in the sky. I've got it centered in my view here, but there are 7 stars in this particular shape. 1, 2, 3, 4, 5, 6, and 7. And that's a shape that a lot of people have heard of before, known as the Big. You've probably heard of it before, and you can say, we can all say it together, the Big Dipper here. So we're
Dipper.
looking at the Big Dipper. There's some extra stars that extend out sort of higher in the sky at the moment and along this way. That's because the Big Dipper is just one part of a constellation, the official constellation of Ursa Major, the Great Bear. So the Dipper are these 7 stars. The bowl of the Dipper is like the body of the bear, and then the long curving handle there as the long tail of the bear, and then some fainter stars that make up the legs for the bear, the hind legs, the forelegs, and then some lines that go out to form her face there. And you may ask why this bear has such a long tail there, and there are all sorts of tales, T-A-L-E, or about why this bear has such a long tail, T-A-I-L. And there's a couple of stories that I know, but there's one that the bear was being chased by some hunters, and Zeus, the king of all the gods, wanted to protect this bear, so he had to think of a way to save her quickly. So he grabbed her by her tail, but he pulled so hard, he was pulling so quickly in his effort to make her safe, that her tail stretched out, and he tossed her up into the sky, where you can still see her in the sky with her long stretched out tail there. But again, that's part of the Big Dipper there in the sky, and that's something that you can find. It's a good time to be looking for it, because it's a bit higher in the sky at the moment. Usually in sort of winter time, it's a lot lower in the sky. Can be difficult to see behind trees or behind the building. But you find the Big Dipper here. You take the stars at the end of the bowl. They'll point you over to, again, a star that's kind of by itself right over here. That's at the end of the Little Dipper, or the Little Bear. But that's a star that if you ever get lost, that's a good star to find, because that is a star known as Polaris, also known as the North Star there. So if you ever want to find the North Star, find the Big Dipper. Those 7 stars, pretty bright, but then take those 2 stars at the end of the cup, and they'll point you over to the North Star. And if I shift my view here a little bit, you can see that that North Star sits right above North and is always right above North, as long as you're in the Northern Hemisphere. Yep.
I watched, there was a question that went by. Somebody was wondering where I'm viewing from. That might be interesting. I'm sort of on the boundary between South San Jose and Los Gatos. So it's actually fairly clear here compared to if you're out in the middle of the valley, you know, Santa Clara Valley or the Silicon Valley, it'll be a lot brighter, and we're usually fairly dark over here. But my only problem is I've got a fair number of trees that are around me, but it is a gorgeous night. I hope it's as good from the person who was asking the question.
All right. Well, it looks like we're just about at the end of our time here together. So we'll have to wrap things up here. But on behalf of the entire De Anza College Planetarium staff, we'd like to thank you all for joining us, and hope you enjoyed yourselves and learned a little something. Once again, we'd like to extend our thanks to the Foothill De Anza Foundation for supporting these virtual star parties and for the captioning. We'll be doing another one of these next month in April, right on April 24th. Let me make sure that I have my dates right. So do tune in for that, but keep an eye on our social media, and we'll have a full listing of when we have all of our star parties coming up. We do have several of them planned in the coming months, so I hope you can come back, check it out again, and hopefully next time, no promises yet, but we're hoping for something a little bit different, a little bit special for the next couple ones coming up. So stay tuned for that. But with this, I think we'll go ahead and wrap things up. Wish everyone a very good evening. Mike, anything that you want to share?
I just want to share a thank you for coming to the show tonight, and we're hoping that very soon we'll start operations at the planetarium again. But it's difficult to know exactly when that's going to be. But it sure is nice to still have folks who are paying attention to what we're doing here at the planetarium.
All right. Well, once again, thank you everyone for tuning in. Check out the links that we'll put in the description below, but have a good night. Hopefully everyone has clear skies and can take a look at some of the things that we pointed out. Definitely check out the moon. Even if you don't have a telescope like Mike has, you can use binoculars and get a great enjoyment of looking at the moon and the stars. So get out when it's clear, be safe, stay healthy, and have a great night, everyone.